review hydrostatics, right? So in hydrostatic, that's when they talk about pressure. So we have to know about pressure in a solid and pressure in a liquid, right? So on a solid, we know that pressure, right? If I give you an object like this, let's say it's a block, the block exerts a pressure on the ground. And the pressure is defined by how much force acting per unit area. So the amount of force acting per unit area, that's pressure. SI unit pascals or Newton per meter squared. Right? And make sure you can get our next unit as well, right? So pressure on a solid is that. Please remember, like in this case, to find the force here is really the weight, which is mass by gravity, right? And you should know how to find area. If on the other hand, now is a liquid, right? Pressure is dependent on, anybody remember online? What is pressure dependent on in a liquid? Density, okay, that's one. What else? So density, correct. Gravity, of course, right? And one more thing, gravity and height, nice. And it's also dependent on depth. So for example, the pressure here will be more than the pressure here, right? So these are the three things that control pressure in a liquid. Density by gravity by depth, and we know the lower we go, the higher the pressure, right? So these are the three things that control pressure. There is a small experiment. If I were to make two holes here, pressure will go out the furthest here. And here it will go out the, well, not as far, right? That shows that pressure is, wait, this is wrong. Other way around. It will go the furthest here and least here. So the lower you go, the greater the pressure. Right? The lower you go, the greater this value will be. Same SI unit, Pascal. Nice. So you need to remember those two things. While we're here, there's something called a U-shaped manometer, and it helps you measure pressure. So if I have both ends open like this, we have atmospheric pressure here and atmospheric pressure here. Because of that, they are the same depth. I remember that? At the same depth. If for some reason now the pressure is larger, so we apply a greater pressure here, right? What will happen is that this part of the liquid will go down and next part will go up. And if you find the change, so for example, let's say this happens. This here, if you use this formula, you'll get something called pressure difference. Okay? So I want you to remember this, right? This is the U-shaped manometer. Right? And it's used to find pressure. Nice, you need to remember that. And then we need to remember Archimedes' principle. Right? Hold on then. Yes, Peter. But this is what we did. Okay, right now? Huh? This was a do factors and make a sequence. That was on the list. Right? Archimedes' principle basically says this. If I give you a liquid, right? And I place an object in the liquid, that object will experience a force called upthrust, which is equal to the weight here. Right? So the upthrust, this is Archimedes' principle in words, well, in a formula form, right? Upthrust, that's the upward force acting here, is equal to the weight is equal to the weight of fluid displaced. Like for all those people who in a pool now or down to Tobago one thing, you will recognize that when it jump in the water, naturally it kind of pushes you upwards. And the reason for that is an upward force. If you want to find your upthrust, see how much water probably comes out and then find the weight of that water. That will be your upthrust. Right? Remember how to find weight, mass of the fluid that came out here by gravity. And please remember that density is mass over volume. So you could use this here to find mass, right? Mass is density by volume. So it's density of the fluid by volume by gravity. So what does it say? If you were to go, for example, in the sea, where the density of the water is higher, your upthrust will be larger, right? So I'm not saying that you wouldn't sink, but it's harder to sink in, let me just say that, right? But your upthrust will be higher in the ocean, because the density of salt water is higher than the density of pool water. Okay, so this is a Kidemy principle. And the next thing Kidemy also said, if I give you an object, right? The object has two main forces acting on it, the weight and the upthrust, right? If the upthrust equal to the weight, then the object is going to float. If the upthrust is greater than the weight, the object will rise until it reaches the top. And then if the weight is greater than the upthrust, the object will sink. So something like a submarine will take in water, and when it takes in water, it will sink because the weight is bigger than the upthrust. And then if the submarine wants to go back up, it will get rid of the water, and then the upthrust will become larger. Now it will start to float, start to go up. When it floats, upthrust equal to weight. All right. So as a little summary, these are the things that we need to know for, right? These are the things that we need to know for hydrostatics. All right, so make a little jot down, and we're going to attempt some questions now on hydrostatics. Right, some of the topics that some of the past papers that we do it now, all be the whole years, right? I think I shared in the group, you know. Let's go ahead and check back there. Wait, before we go into Tobago, Soraya and Tobago area. Wait, that's line. Check it back. I think I sent this in the group. Who was it? 1994, I think. Anybody seen it? Check in the group. I think I see it. Hold on, I gotta try and share. It's 2005, 2016. Somebody that's older years. And I'm older than that too, when I find it back outside. But I just wanted to have questions so you can practice while you're on the beach in Tobago. This side, any good? Sorry, let's check it. You can see the game. Right, so we'll be using our booklets as well, right? Let's see if I can share it. On the class. Hold on, then. I need to go back to the page man for the signal switch. Hold on, now more people to go. That's sort of one. What's this one here? Why are we here? What's the answer to this one? I just must A, B, C, or D, right? Right, I only see one answer. Anybody else have an answer? What's the answer here? Right, a balloon filled with hydrogen gas accelerates upwards. The balloon must therefore have displaced a weight of air. They're talking about what then? When they say displaced weight of air, what are they referring to? Anybody want to like it answer? Please. Anybody could answer. When they say displaced weight of air, what are they referring to? Upthrust. Good job, Tiana. Thank you for responding. Right? So check and see which one is the answer. Upthrust is what? Is the upthrust less than the weight? Why is the object going upwards? Right, so message your answer A, B, C, or D. Good job, Tiana. That is correct. Good job, Nerissa. Sophia, good job. Correct as well. Any fellas there? Anybody there? Michael. Good job, Serena. Correct. Michael, are you there? Presley. Serena, yours correct. Vandina. Pauline. Right, so yes, most of you all said C. That's correct. Because the balloon has an upthrust acting and a weight. And because it's going upwards, the upthrust is greater than the weight. All right. So yes, your answer is C. Very good. Answer is C, right? Hold on, I'm just going to the question that I want us to try. All right, the question here was shots. The graph. All right, I wouldn't make all do that graph. All right, no, I had to skip that one, right? Because I didn't realize it was a graph. Let's go back to topic by topic. Right, let's go to hydrostatics. Right, one for 8 marks, easy 8 marks. Who got this quick? Use gravity 10, right? Easy 8 marks in. Right, work it out, message your answer, please. Nice answers coming in already. Two minutes again, correct it, yeah? Okay, time up. So let's see what we have. Most important, correct SI unit. So we're good to go. Right? Everything is in the right SI unit. So they want us to calculate density. Density is equal to mass over volume, which is 15,000 all over. The volume, 1.1 by 2 by 2.5. And that will give you a value in pascals. I actually have a calculator today. Right, I have 27.3. I told you all 15,000, which is the mass divided by 1.1 by 2 by 2.5 here. Right, but that'll be the density of, I write it wrong, sorry. The actual density. And then they want to find the pressure would be exerted by B, so we know that pressure is force over area. So the force will be 15,000. Remember that's the mass multiplied by 10 all over the area. The area in the bottom is 1.1 by 2. Right? So the final answer I have is 68,181.8 pascals. Nice, copy down. Let's try next one. This is part 2 here. And this is part 2. Copy down. Let's try the next one. By then put plus here. Yeah. This 5 years plus 50. That's what you do here. Yeah, right. Yeah, okay, right. Very good. Okay, great. Just very matrix like that. Diuses, very matrix. Matrices, use matrix pattern. Okay, so, right? Try the next one here now. A little tricky. I'll give you us 8 minutes on this one. It's a little bit trickier. Yes. Right. Yeah, we'll come down. Pretty arrow. All right, good job, Sophia. Yeah. Excellent. Oh, yeah, four. Yeah, set up. Right. What you put? What name? What shit? Shit, what shit? Keep big about something. What is that? What? What I say about you have a turn. Everybody you can trade, you pick one, two of them, I think. Michael, Michael. Go thing already, find it, do something. Yeah, that method. Find the environment. Yeah. right? Let's see what we got. So we know what Academy's principle is. Academy's principle says that trust, right? For a body that's wholly or partially submerged in water, trust is equal to weight of fluid displaced, right? And we know how to find it, mass of the fluid by gravity, or, right? Or you can use volume of, sorry, density of the fluid by volume of the solid by gravity, right? Either one of those can help you find out trust. So the asphalt is made of steel. Explain how it's able to float, right? So the yacht is able to float. Main reason is that its upthrust is equal to its weight. Right? So what you have to see here is that yes, also although the density of steel is more, the weight of fluid displaced by the yacht, all you have to do is say the weight of fluid displaced by the yacht is equal to the weight of the yacht. Right? And we all know this happens based on how it's shaped, right? Based on the shape of it. Lastly, calculate the volume of seawater displaced by the yacht. So we need to get the volume of seawater. So remember, they say float. So we know in part 3 here that upthrust is equal to weight. Right? But look at what I'm going to write. And I'll show you how things will cancel off, right? We know upthrust is density of the fluid by volume of the solid by gravity. And we know the weight is the mass of the yacht, according Y, mass of the yacht by gravity. So the gravity will cancel. Remember, they want us to get the volume of seawater displaced, right? Right now, they gave us the density of the yacht somewhere, of the steel, right here. And we know that mass is density oh wait, they did give us the mass of the yacht. That piece of the question missing all it. They gave us the mass of the yacht. That was the part before. So to find the volume of the seawater, it would have been the mass of the yacht divided by the density of the salt water. Can't remember I think it was 2100 or something. I think it was 2100. Right? So sorry about that, it's missing that. Right, but at least right on till here. So the mass of the yacht is 2100 and the density of the seawater is 1025. So when you divide 2100 by 1025, 2.05. I think it was somewhere around there. I think it was around 2100 or something. Right? We can look back at the year 2012, number three. Look at A and B. Right? But you have to equate and cancel, right? Right? Use the value as 2100 for now. Right, one more. Just one more, right? Do the CC one here. And then I'll give you a clue to it. So, 3 minus 5. That is correct. You see it? Just minus 5. Minus 5. Second. Sign. Change the sign to make positive, become negative. It should become from. Again, you have an next step to do. You have to multiply this by this. Should be a whole numbers. That is last one, right? Yeah, Michael, send some answers to this one now, please. I just forget these things fast. Not because it's fun. I can make you see that. Don't have to. I just forget. Quick way, just go quick. Huh? I think the rejected. That's very. Don't be able to see something in that way. This is not my thing. This one, I don't care. Normally, think they do know, do I want to buy it too much of the time and time. Well, I mean, like, I mean, like, to get the steps. It makes it, so I don't know. Well, we might still remember the step. It's fully, fully, please, depends on the right. You yes, you know. Just forward. Time almost up. Michael, any answer to that? Alright, let's wait on you, Michael. Mikey, there, Mikey. The Mikey, something na way. Alright, Michael, go on. Let's see what we have here. The one again, density, same thing. Mass and volume, same kind of question. Energy is equals to the right? And the volume will be 2 by 1.4, right? Right? Not by 140, yeah? So 20160 divided by 2 by 1.4. Right? I got 7,200 kilograms per meter. Pressure, we know that pressure is force acting per unit area. Okay? Force acting per unit area. Calculate the pressure exerted. So pressure is force over area. So the force we know acting is mass by gravity all over. Oh shucks, I can't believe I made that mistake. I forget to multiply by the height. And I'll see it now. Sorry about that. So this one is 72,000 tons. And the one on top is 2,400. Right? All right, nice. Right, so that's our hydrostatics there. Let's do a little Kahoot now. Sorry, for those who write, sorry, what up here now. Anybody else got those values? Somebody else see? Somebody have 8,000 something. Check it out. Guys, clear now. Michael said the answer. Michael, how you get up? Okay, make it matter. Not again. Whole numbers. Yeah. All right, nice. Let's take a look at this last Kahoot and we done. Come, let us see you. That's a screen. That's a screen. Nobody can see it then. It's a screen. How do you see you? Yeah. Oh, we'll check that. Right, log in here. Freedom. Come here. With that is oh, this one. Like point like this. Okay, how you can take kilometer. And right. Sorry, multiply 600 kilometers. And by just that, you multiply by that way. That's 600 kilometers per yeah, twice. Right, but remember, that will be an answering centimeters, right? I think. Right, anybody else? I'm starting. Michael, the commercial holiday, only 5 people log in. One live. Anyway, I start. Next one. Welcome to ask. This is Hydrostatics, you do? Funny writing. So we are coming up there, Banduna, nice. Wait, no, this is the wrong thing. This is not hydrostatics. What did I click? I think you click hydrostatics. What did I click? I clicked. Yeah, yeah. Yes. What do you think? Well, so you know what? Here's it. Yeah, I'll do that. Yeah. I think I clicked on the wrong thing on the box. We're doing still, right? Alright, it's a mixture of mechanics, so we got to do it. Yeah, and it's yeah, now PUBG and you can log out. Don't take us so much. Find the option quick. What do you got? All right, nice progress there. 3 more. Calculation coming in. Nice one. I like this one. I like this one. It's similar to what we did a little while ago. Tight at the top, but Sophia pulling away, Serena coming back, Gianna coming back. It's right, tight at the top. Put them in order, right? First have to be float, then sink, then rise, right? Put them in order. Oh no, you gotta say what all happened with the first one, so that will be float. And then put them in order, right? Put them in order. Alright, let me see if let's see when it's all first one for the year, Bandina come third. Gianna second. Wait, Gianna come back. Good job, Gianna. Well done, Sophia. Alright, so you win first one for the year. Keep on notes there, yeah? By the all night, so we're gonna see who's champion for the two. Alright. Alright, Olive, you can go back in the beach now. Alright, you're going to go back in the beach, but the lesson starts as normal this week here. Alright, bye. You're going to log out. I'll see you all next week. I'll check back this stuff, find the speaking notes. But this conversion, every 1 centimeter is 25,000 centimeters. I know for sure that's what it do here, right? So 2.25 centimeters squared is like saying 2.25 centimeters, which you would multiply by, and then 1 centimeter, which you would multiply by. So it's like multiplying them together. Yeah, so that should be the right thing. But remember your answer being meters and then we are going to divide it by. No. This value here in centimeters. I'm not sure to go. So we take 2.25 multiply it by 25,000. It's 56256, right? That's the value in centimeter. Next one will be 25,000. Then let's convert kilometers. Centimeters to kilometers is what divided by 1,000. 1,000. And 1,000 meters. They divide by 100. So we got 100. Directly 100. So you divide by 100. 1, 2, 5. You multiply 156. 2, 5. Let's see. But should be smaller. I don't think value. Why are we have to multiply something? By what? By this, by this. No. I said to multiply this bar. Action. Sure. Without the diagram, you cannot find. No, this one correct. I'll check on what's that. The diagram we do not drawn to scale shows the cross section of the cylinder. Child. Initially, jar Y is empty. So next. Contains water height of the 2 minutes before the amount of jar. So pi r squared h. So the height is 3D. Like the diameter. That is 2 perfect truths. And square. Right? That's the given diameter. So the use is half of that. Right? But I'll go with 4, I'll cancel. So you get 9, 5. All of the water is now poured into the Y or hydrogen. Remember the volume is 9.5 squared. We've already saved volume here. Right? But I is fine volume. Volume is 5 R squared. What is R here? What is R here? For this one. Squared by each. So if you do the math, so that pi squared on 4 by each. 9 pi squared. Pi and b squared will cancel. Pi plus 4. So you see, this here is what we're doing. So the volume, same way you find volume. Pi by r squared by h. So all right, so we technically finish the whole thing. Right, good afternoon, guys. Happy New Year. Right, the intention today was to really start module one time, but not much people tuned out. But I still mind do module one. Um, but I want to find out, anybody missed parts of module two in this, from you all? If you all missed any part of module two, remember module two is digital and, analog, right? That's where we did logic gates and op-amps. Just do me a favor now, look back and see if you have missed any of those things. I could also use this class and go over that, right? Because I know one or two of you have missed the holiday classes. Check and see now, please. If all of you all did it, then we will jump straight into module one. Right, just message in the group now. Let me know if you all did it or not. Check back at the beginning. That was the first thing I would have done in unit two. We started here and then we finished off here, I think. Any advice here earlier? Everybody did those topics? You all here, right? Did them already? Yeah, we did your everybody did already. Okay. All right, let's jump into module one then. Right, I'm not sharing this handout as yet, right? Still have some mistakes, something. Right? So we have most of this term to kind of focus on module one, which is kind of the trickier module. Is made up of electrostatics, electricity, and magnets. Right? Those three things make up this module, right? Right. So if you look here, hold on, right. So the first part of module one, and I will share this with you later on, right? Not yet. The first part of module 1 is things that you would have done in Form 5 and 6, right? Where we talk about electric fields. You should remember about electric charges and things, right? So we're going to go over electrostatics, right? We're going to go over electrostatics and introducing the concept of electric fields. Just like how we had magnetic fields and gravitational fields. Now we have to focus a little more in depth in something called electric fields. One of the good things is that you would have covered this module already, right? So everything that we do is revision and getting ready for exams, right? So what you can also do for me is if you run over your notes, you can point out, okay, well, I struggle with Kirchhoff's law, I struggle with understanding the classicals. So I'll go a little bit slower and I'm going to do more practice on those things, right? All right. So let's go into electrostatics. I'll go through this handout. You don't have to write. I'll make it available.